Hello, Atal Innovation Mission community, teachers, students, mentors, all of you. I hope all of you are doing well. The Shubham Gupta this side, Innovation Lead, Atal Innovation Mission. We are coming up with a very special session today with Yashvardhan Marda. He is a student of class 12th, has excellent achievements in both the academics as well as extracurricular. So today we have the 30-40 minutes of very exciting session on astrophysics. It might be new to somebody, it might be known to already some of you. So Yashvardhan has kept it very nicely engaging session for all the students of 6th to 12th class. And yes, he has so many awards to his names, both in the academic as well as in the extracurricular session. So this session we have kept it for all the students of 6th to 12th class again, and you can ask any question related to this topic in the YouTube live chat, and we would be taking it at the end of the session. So without further ado, I am handing it over to Yashvardhan to take you to the world of astrophysics. Yashvardhan, over to you.
Thank you. Hello everyone, I'm Yashvardhan Marda. I'm currently studying in 12th standard in Modern School Barakhamba in New Delhi. I'm extremely fascinated by the laws of physics that govern our universe. My love for physics began at a very young age through simple observations, understanding the movement of various celestial bodies. To stimulate my interest in physics, I in fact started my own YouTube channel, Mr. Physics, where I teach a variety of concepts of physics as per my understanding in a very simple manner. I feel that we are all very lucky to be born in this country where science was introduced and encouraged at a very early age of human existence, and it has grown ever since. It is, in fact, advancing at the fastest pace, if I'm not wrong, in our country. And so, without any further delay, let us all together dive into the intricacies of astrophysics, which I believe will provide us insights about the mysteries surrounding our universe. So, I don't think so. We can go on with any session without clearing some of the misconceptions and the myths surrounding our universe. Um, so, one of the misconceptions is that do you all believe that Mercury is really the hottest planet in our solar system? Let us just together analyze it. We know the chronological order in which the planets revolve around the sun. So there is Mercury, Venus, Earth, Jupiter, Saturn, Uranus, and Neptune. So it is very common for us to think that Mercury is the hottest planet because it is closest to the sun. Um, but however, this is in fact not the case. What happens is that although Mercury's distance from the sun is the closest as far as planets are related, but Venus is in fact the hottest planet with an average temperature of 462 degrees Celsius, and Mercury's average temperature is 430 degrees Celsius. So now you all must be wondering why is that? I'll answer that. Basically, Venus's atmosphere is majorly composed of carbon dioxide gas. Now, carbon dioxide, as we all know, is a greenhouse gas. And the function of the greenhouse gas is that it absorbs all the sun's radiations. And by radiations, I mean sun's heat. It traps all the sun's heat. And since Venus has more amount of carbon dioxide than Mercury, therefore, Venus will attract more sun's radiation than Mercury, and therefore its temperature rises. This is one of the facts that myths, in fact, that we all are confused about, and it was really important for I thought it was really important to clear this up that Venus is in fact the hottest planet, not Mercury. Another misconception is that Saturn is also not the only planet with rings. Now we all know Saturn has so many beautiful rings. Uh, they are visible through telescopes and not through naked eye, but through telescopes. But in fact, every planet after Mars, till Mars, the planets are known as inner planets. And after Mars, after the asteroid belt, that means from Jupiter, all the planets are outer planets. So Jupiter, Saturn, Uranus, and Neptune all have rings. Now, the question that arises in our minds is that why can we only see Saturn's rings and not Jupiter, Uranus, and Neptune's rings? Basically, the rings of Jupiter, Uranus, and Neptune are made up of dust particles. Now, if you want to see anything, suppose I want to see this remote. How will I see this remote? Light has to reflect from this remote and reach my eyes. Then only I can see this remote, right? But we all know dust is a not very great reflector of light. It absorbs most of the light and reflects back very minimum amount of light. Now, since these planets' rings are made up of dust particles, the rings, basically light after reflecting back from the rings, do not reach our eyes because light has been absorbed by the dust particles of these rings. So that is the reason why we cannot see rings of Jupiter, Uranus, and Neptune, which are in fact there. As you can see also in this figure, planets with ring systems include Saturn, Jupiter, Uranus, and Neptune. So these were some of the myths, and now let us move on to the next topic. We all know that ISRO launched Mangalyaan, um, the Mars orbiter, revolving around Mars, and since then we have NASA launching Perseverance rover, Curiosity rover, all have touched down on Mars very safely. But the catch here is that we have never tried to land on Saturn and Jupiter. Now, the reason for that is that Saturn and Jupiter are gaseous giants. Now, for anything, if we want to suppose land our rover on these planets, right, there must be something to land on. There must be a land. We cannot just uh, launch a rover and make it fly in thin air, right? There must be a land to land on. But since these planets are gaseous giants, they don't have any land. It's just gas all around. As you can see, this figure was clicked by the Galileo atmospheric probe, and this was the closest we have ever gotten inside Jupiter, and you can see that it is just full of gas. No land can be seen any far away. This picture of Saturn was taken by the Cassini spacecraft, again, a gaseous giant, no land. So, since there is no land, we cannot land our rovers, as simple as that. Now, I'm sure you all must be really fascinated with this topic. To be honest, it is one of those topics in astrophysics that is really close to my heart, black holes. Now, there are really you all must be having questions or myths surrounding black holes. That does it help in time travel? What are wormholes, white holes? What is the relation? So I'll be answering them all. So let us first understand what do we mean by black holes from a simple home experiment, which we can all do in our homes. So let us take a trampoline and let us take 10, 20 shot put balls. Now shot put balls because they are really heavy. So we are taking 10, 20 shot put balls and we are we are placing those balls at the center of the trampoline. And now let us let the trampoline represent the fabric of space. Fabric of space, I mean empty space. Let it represent empty space. And the shot put balls, when kept at the center of the trampoline, we will observe that the trampoline will bend by a huge amount from the center. Now, in fact, this is what we call as gravity. We are not talking about Newton's gravity here. We are talking about general relativistic gravity given by Einstein. Now, basically, the bend created by these shot put balls in the fabric of space time, that is the trampoline, is what we call as gravity. And let these shot put balls represent a black hole. So now the bend created by that would be so large that it would create almost, you can say, infinite gravity. And there is a mathematically demarcated boundary around a black hole, which is known as the event horizon. Now, you all must be wondering, what if the sun becomes a black hole? Will the Earth be affected or anything like that? So, to answer that, no, the Earth will not be affected because the light also cannot escape a black hole, but only when it falls into the event horizon. If we are beyond the event horizon, by beyond I mean if we are outside the event horizon, we would be really safe. But if we fall into the event horizon, we cannot escape a black hole. Light can also not escape a black hole. And we can only escape a black hole if we travel faster than the speed of light, which is not practical at all. As far as today's technology, it is not possible at all. So this is what I mean by black hole, that it does not allow even light to escape. It creates a bend in the fabric of space time, creates infinite gravity. So basically, these are really, they are not humongous per se. Uh, they are just glutinous beasts that are existing in our universe. And yeah, so let us move on to another very interesting topic. Now, in 2019, there were three Nobel laureates which were awarded the Nobel Prize in Physics for establishing the fact that there is a supermassive black hole at the center of every galaxy. So that means there is a supermassive black hole at the center of the Milky Way, our neighbor Andromeda galaxy, and every other galaxy, like for that matter. But what we observe is that there is a galaxy which goes by the name Abell 2261. And last radio emissions suggested that supermassive black hole's activity, in fact, had taken place 50 million years ago. Since then, we have not observed any evidence of the black hole uh, at its center of the galaxy. Now, you all must be wondering that how has the black hole just vanished out of thin air? Is it still there? If it is there, why can't we see it? And and to be honest, this is a really open-ended question because scientists are still researching about this fact. My thought is that how do we observe black holes, right? We cannot just directly observe black holes since they don't allow light to pass through. Light does not reach our eyes. We observe black holes through the emissions emitted by the black hole. And X-rays, gamma rays, electromagnetic radiations are only emitted by a black hole when it feeds upon its surrounding matter. For example, let's say this is a black hole and this is a star. So whenever the star comes inside the black hole's event horizon, the black hole will gulp it. And when it gulps it, it releases out radiations, which we on Earth detect through various observatories all around the Earth. Now, what I feel must have happened in this galaxy is that the black hole might have gone out of material to or matter to feed upon. And since there is no matter to feed upon, it will not emit radiations. And since it will not emit radiations, we would not be able to detect those radiations on Earth. And that is why the black hole has just gone silent, I think. It is still there, it is of course there, but it has just gone silent and we cannot detect it. I think that this might have happened. Of course, you all are open to think and research more about this because it's an open-ended question. Let us move on to planetary science. So we know that this is the sun, this is the earth. The earth revolves around the sun, spinning like a top, like this, right? And we all must be thinking like, if the earth revolves around the sun like this, then every planet should revolve like this only, right? But Uranus, in fact, instead of revolving instead of spinning like a top on its axis, it actually rolls like a ball. So if we roll a ball on the earth, on the ground, that is how Uranus revolves around the sun. It rolls like a ball like this. Now, why is that? Why can it just not spin on its axis? Why does it have to revolve around the sun, like roll around the sun, basically? So the earth spins on its axis because the axis of the Earth is tilted at an angle of 23 degrees, roughly speaking. On the other hand, Uranus's axis is actually tilted at an angle of 90 degrees. Now, since it is tilted at an angle of 90 degrees, instead of going like this, it goes like this, right? So it rolls like a ball instead of spinning like a top. Another really, I previously talked about how we are not using Newton's gravity and we are using Einstein's gravity to explain the bend in the fabric of space. Now, why are we not using Newton's gravity? What is the problem with Newton's gravity? Newton was not able to explain the orbit of Mercury. It was not, Newton's gravity is not very accurate. The universal law of gravitation, as we call it is not very accurate because, firstly, it was not able to explain the change in the path of Mercury, whereas general relativistic gravity could. Now, I'll explain what do I mean by this. Basically, we all are affected by sun's gravitational pull, right? All the planets are affected by sun's gravitational pull. But since Mercury is the closest planet to the sun, the bend created by the sun, just imagine the sun, our solar system is the fabric of space-time. The sun is like the shot put ball, and it is creating a bend. So the planet which is closest to the sun will be affected most by that bend. You can imagine this in this scenario also. I'll explain. Take the same trampoline, put the same shot put balls, take a marble, and just roll the marble very close to the center of the trampoline where it has been bent. You will observe that the marble, in fact, would change its path. It would not just go like this. On the other hand, if you take the same marble and roll it around the edges of the trampoline, it will more or less it will remain in the same path. Now, when I say the edge of the trampoline, I mean the planets which are at a very far distance from the sun, which is the shot put ball. So the marble which is very close to the sun, it changes its course, changes its path, its trajectory. So that marble is in fact Mercury, and Einstein was able to explain this using this, and he could explain why Mercury's orbit keeps shifting. As you can see also in this picture, this is the sun and this is Mercury, and Mercury's orbit keeps changing and forms really nice patterns. Like these are like, I think, patterns of a flower or petals, for example, and they form very beautiful patterns. And so this is why. And in fact, if we you could all just go on the web, go on net, and just draw these patterns. You would also think that, wow, this is really interesting. And another really interesting fact is that, let us take Saturn, right? And hypothetically, I'm speaking, let us take Saturn and just throw it in a pond full of water. What will happen? We all would assume that since it is so heavy, it will sink inside water, right? But the catch here is that when we are talking about sinking or floating, we should not talk about how heavy the planet or the body is. We should rather talk about its density. And for anything to sink, its density should be greater than the density of water. And for anything to float, its density should be less than the density of water. Now, Saturn, it will be really interesting to know that Saturn, in fact, when we throw it in a pond of water, it will float, it will not sink because its density is less than the density of water. Moving on, now this is a topic, again, extremely interesting, very open-ended. People have really different views about it. You all must be wondering, like, can we do time? Is time travel possible? If it is possible, how is it possible? And can we go back in time, or can we go further in time, or can we do either of them, or can we do neither? So I'll be answering all of these questions in a very simple language. So I'll be speaking in a very diplomatic manner because, again, we do not know what technology holds for the future, right? Talking about right now, no, time travel is really difficult. It is almost impossible. Now, maybe in the future it may be possible. We do not know that for sure. But as of now, in fact, we can observe time travel. Now, how is that? Let us do an experiment again. we are two friends. Let's say there are two friends. One of those friends is sitting at home on his chair, just relaxing, and another friend is on an aeroplane. Now, for anything I explained earlier in my speech that for anything to cause a bend in that fabric of space, and now I'll in fact call it the fabric of space-time. We all know there are three dimensions: length, breadth, height, and there is another fourth dimension, which is known as the dimension of time. Now, for anything to bend the fabric of space-time, it should have either mass, energy, or momentum. These three things should be there. Otherwise, the fabric won't bend at all. Now, when we are sitting at home, if one of that friend is sitting at home, it is having no momentum, right? And since it is having no momentum, it is not bending the fabric of space-time at all. On the other hand, the friend which is in the aeroplane, traveling in the aeroplane at a very fast speed, it is definitely having some momentum compared to us. I'm not saying that momentum is very large to account for a very large difference in time, but as compared to us, it is very large. So, since the momentum is very large, it will cause a bend in the fabric of space-time. And now what happens? How does that affect time? So I am again emphasizing on this fact that the fabric of space is not fabric of space, it is fabric of space-time. So momentum, when it bends the fabric of space-time, it actually elongates that time dimension. If you might think like this, it elongates the time thread, you can say. It stretches the time thread. So the person traveling in the aeroplane will stretch that time thread because of its momentum, causing a bend in the fabric of space-time. On the other hand, the person who's sitting at home will not cause an elongation in the time thread because it is having no momentum, creating no bend in the fabric of space-time whatsoever. Creating that bend in the fabric of space-time and further elongating that time dimension actually makes the time for that person traveling in the aeroplane to go slow as compared to the person sitting at home. So this is one thing which we are the difference in time is not at all practical. Like the difference in time between the person traveling in the aeroplane and the person sitting at home. And let's say both the friends are having quartz clock. Quartz clock can measure time in microseconds. We synchronize it. When the person lands after traveling in the aeroplane, we will observe that the clock will run slower as compared to the person sitting at home. I explained the reason just now why. So this is how we can observe time travel right now in this age. But the time difference is so less that we do not take it in account. It will be less than 1 microsecond, and that is really less. So it's not practical for us to take that difference into account whenever we do our calculations for research or anything. Another very interesting observation of time travel is, okay, I'll ask you a very, you may think this is very a ridiculous question, but if I would want to know that can we see dinosaurs again on Earth? Now, you all must be thinking that how can we do that? Dinosaurs existed like how many 400 million years ago, I think, if I'm not wrong. So, but I'll just answer that. How can we see dinosaurs on Earth right now? It is not practical. Theoretically, it is possible. Let's say we are at a distance of 400 million light years from Earth. This is a very far distance. We are not going to go that long. But let's say we are having a telescope with such a, let's say, with such a great focal length that it can in fact see Earth. Like 400 million light years is a lot of distance. And let's say we have a telescope and we are observing Earth from 400 million light years right now. What we'll see is that we'll see dinosaurs on Earth. Now, how is that possible? Basically, what we are seeing through our telescope is not what we are seeing right now. 400 million light years. One light year is the distance traveled by light in 1 year. So 400 light years would mean the distance traveled by light in 400 years. So the light, after reflecting back from the dinosaur's body, it has been traveling since 400 million years. And if we are at a distance of 400 million light years, the light will reach our eye after traveling from those 400 million years. And that is how we would be able to see dinosaurs. So that is how, in fact, our telescopes are acting like time machines. The Hubble telescope, the James Webb Space Telescope, these all are such great telescopes, and they can see through so many million miles, million light years, not even miles, that they are in fact acting as time machines. There are, I would like to talk about some really interesting facts. These facts are not strictly contingent to astrophysics, but but physics in general. And I thought I should be discussing them because they are really very interesting. So you like the first question is that can we compare the number of trees with the number of stars in the Milky Way galaxy? You all must be thinking that obviously the number of stars should be more. We are anyways having a lot of problem with our trees, global warming and everything. But the fact is that the number of trees is actually 12 times. Number of trees on Earth is actually 12 times the number of stars, all the stars combined in the Milky Way galaxy. I'll show you one figure also. Yeah, there are approximately 10 trillion trees on our planet and 300 to 400 billion stars in the Milky Way galaxy. Now that is roughly 12 times. So that is a lot. And still we complain about, cutting trees. We are not having enough trees, global warming. So yeah. And one more interesting fact is that, okay, I want you all to just stop for a second, whatever you are doing, and just observe the color of the t-shirt you are wearing. Like I'm wearing a green colored t-shirt. Now, have you all ever wondered why is it that we are seeing the color as green? Like obviously the dye of the color is of green only. The dye is green only. But why are we seeing that green color? What is the reason behind it? There must be a scientific reason behind it. I'll explain. Light is made up of seven colors, the seven colors of the rainbow: Vibgyor, violet, indigo, blue, green, yellow, orange, and red. Now, if I talk about me, for example, I'm wearing this green colored t-shirt. So what is happening is that, again, if I want to see anything, if I want to see this remote, light has to reflect back and reach my eyes. So what is happening is that the green colored light, in fact, I'll go like this. All the lights, all the colors of the light, except the green color, have been absorbed by this t-shirt. And only the green color is being reflected by this t-shirt. Now, I'll explain it in a better manner. Seven colors of light coming at me like this, the green colored light being reflected back, reaching my eyes, and all the other colors, violet, indigo, blue, yellow, orange, and red, have been absorbed by this t-shirt, and they are not, it's not reflecting it back. So since only the green colored light is reaching our eyes, that is why we are seeing the color as green of that t-shirt. Again, you can also just try this, see the color of the t-shirt you are wearing and identify the light, the lights, the colors of the light which have been absorbed by your t-shirt, and the color of that light which has been reflected. The color of the t-shirt will be the color of the light that is being reflected, and that is how we can see the t-shirt which you are wearing. That is how we account for the fact that this is in fact a green colored t-shirt. That is how we differentiate. I would move on to the last question, and this is again a very interesting question. We all use pillows to sleep, right? We might, some of us, obviously, you all must agree that they are comfortable. It provides us comfort. That is why we use pillows. But for everything we do in our daily lives, right, there must be a scientific reason behind it. Now, what should be the scientific reason of using a pillow? I'll explain. What happens is that the our head is denser than the rest of our body parts combined. The head is denser than the rest of our body. Now, since it is denser, it is more dense. If we do not use a pillow, let's say, the head is more dense, so our body will slightly go inside the bed, tend to go inside the bed because the head is denser, and it will become inclined like this if you are not using a pillow. This will account for a faster rate of blood flow from our brain to our legs. And since the rate of flow of blood is faster, it will not allow us to sleep. Our body would be active. On the other hand, to reduce this effect of head, we use a pillow and make our body from inclined to straight. Obviously, let us imagine, we know if we use an inclined plane and we throw a ball, it will reach faster, just like the blood flow is fast. On the other hand, on a normal plane like this, when we use a pillow, the blood flow has been reduced by is reduced by a considerable amount. And because of that, the blood flow, since the blood flow is really less, it provides us like we are not active. If the blood flow is less from our brain to our legs, we are not active at all. And that is how we can in fact sleep. These are the answers of the questions I discussed previously. I would just like to all I would just like to give you all a minute and read through these answers. That is all for my presentation on the intricacies of astrophysics. Um, I hope you all enjoyed it, and it was a very new and exciting session for me as well. If you all have any doubts, you can go ahead and ask, and I would love to clear them. Also,
Yeah.
if you want to reach out to me, my email is yashvardhanmarda@gmail.com. So I would be really honored to help you in any of your doubts.
Thank you so much, Yashvardhan, for very insightful session. Uh, we have three questions in the chat box. Okay. I'm asking one by one to you, and you can answer as deemed fit. Okay. How
Yes.
are black holes detected? They don't give light.
Okay, I'll answer that. Although black holes don't give, I'll explain in detail. There is the event horizon, which I explained, and outside the event horizon, there is an accretion disk of a black hole. Now, light accretion disk is outside the event horizon. So whenever the black hole feeds on matter, the radiations which are emitted are due to the friction in the accretion disk. Matter is surrounding in the accretion disk, and after that, it is thrown inside the event horizon. But for that time, matter, when it surrounds the accretion disk, due to friction, due to viscosity, the matter gets heated up, and that is how light is emitted. It is not emitted beyond and beyond the inside the event. When the matter is inside the event horizon, it is emitted when the matter is revolving in the accretion disk. So that is how we detect the radiations emitted by the black hole. By radiations, I mean X-rays and gamma rays emitted by the black hole, and we detect that on Earth.
Sure. Thank you, Ashwardhan. One question is looking like a confirmation. Is moon tilted at 5 degree?
I'm not sure about the approximate
Yeah,
figure, but uh, I'll get back on that.
sure.
If you could just leave me the email of the person that asked,
Done.
or
Done thing. One more question. How will we look at ourselves with the telescope? I don't know, matlab, in what context she has asked, but if you have gotten the context,
how will we look at ourselves?
yeah,
How will we look at ourselves? I didn't understand. Like,
yeah, I'm a bit okay. One last thing is, this may be the context for some, and this might not be the context for some. So you have asked one question about the pillow thing, right?
Right, sir.
So one person is asking ki why do doctor tell some persons not to use pillow? There might be another
There
scientific
might
reason
be
for that.
there might be they may have problems with their neck or something. That is a biological reason. I have answered with respect to physics. What is the physics
Right,
involved? How does it help it sleep?
sure. That is it, Yashvardhan. I guess we have taken all the questions in the chat box.
Yes, sir.
Okay, and if there would be any other question posted to us, we will definitely forward it to you for the better answers and the well-framed answers for that.
Yes, sir.
Yeah, and thank you so much, Yashvardhan, for putting light on this very important topic. It is a brewing field as well. Many of the young budding scientists are taken up this field of astrophysics, and you might be another one who can guide them as well. Stay in touch with the Atal Innovation Mission, and
I
yes, we will definitely have some other sessions as well going forward.
I
Yeah,
would
based
just
on
like
the
to
feedback.
conclude by saying that I'm really grateful to the Niti Aayog team for believing in me and giving me this opportunity to share my views with all of you. It has really been an honor, and yeah, I'm just really grateful. Thank you.
Thank you so much, Yashvardhan.
Thank you.
So, AIM community, you can also post the questions on aim.gov.in. Okay, and we will take those questions with Yashvardhan and answer back to you in 7 days. Okay, so thank you.
Perfect.
Thank you, Yashvardhan. Thank you, everyone, for joining
Thank
this
you.
session.